everybody. I hope there's some people here. For those of you who don't know, I actually did a long half-hour presentation last week using this YouTube streaming and tried to share it with folks on Facebook as well. Managed to not stream it to anybody. Had to do it again on Facebook only, and then got no comments and no nothing. So I hope that this is streaming out to you. It literally says now you're live. It says I've been live for a minute. It says I can stop streaming, but that's exactly what it said last time. I did figure out what happened last time, finally. It actually streamed to a live stream that I started over a year and a half ago that still was in the system somehow. So Brady found that for me, so thank you, Brady. So for those of you who are here, if you wouldn't mind either saying hi on Facebook on the post that I added there on the AT Makers group, or right here in the chat window. So I see Jake MacGyver says, "Can hear you loud and clear." Excellent. Glad to hear that. I was so frustrated last time. I was spitting nails. I was so mad. So let me go ahead and bring up kind of a little bit, since I don't want to waste your time. You came and joined me. Let me show you. Actually, my light's a little off. You can see my backdrop, but who cares? So let me show you a few things that I'm going to talk about on the next thing. And before I do, actually, this is really cool. Any of you who have seen us work with the IX, the Toby IX, we had a mount for it, and the way that it worked was it mounted underneath a VESA mount on the back of a monitor, and then it would actually wrap around the monitor and let you position it. And the reason this was so important was that it actually let you have this stay aligned with your monitor, and if you rotated your monitor, which some people have to do, it kept it aligned as well. So it was really kind of cool, but we didn't have one for the 4C. So I got to thank Ryan Olson, our friend Ryan Olson, 3D printing expert, took my designs for the IX and fixed it, and came up with this much improved version for the 4C. So it kind of works the same way. It connects to the VESA mount here and here. It'll do 75, 100, or actually 50 millimeters. Very few things actually use the 50 millimeters, but he added them. This sandwiches in on the mount, and then these are friction mounts, just like they used to be. And you can have as many of these links as you need. There's different length links that you can create. Then if you look, this actually wraps the 4C. One of the problems with the 4C is it doesn't actually have any mounting holes. So this fixes that. So we'll post this up on Thingiverse. I'd like to, if any of you guys would like to print these and try them, Lucas Stuber would be a good person to test this out for us. Overall, it is a really nice design and a good upgrade. So we'll talk about that, probably not on the PCB. I'll probably make a separate post for that and talk about it. Let me see here. I see no other comments on Facebook. I just see the Jake comment here, so I assume you guys are still hearing me. Hope so. As far as the PCB stuff we're going to talk about, we're going to actually talk about, I think, 3 different projects. We're going to have one on kind of the basics of what do you mean make a PCB? What does that mean? Why would I ever do it? And I think I have 3 projects. So the first project is going to be basically a switch isolator. And the idea with that would be to take something like this capacitive touch switch, this candy corn right here. Maybe overhead's a better way to show this. So this candy corn right here. The problem with this is that if you want to control something more with a motor, something that is an inductive load, something that's got a higher current through it, which often is the first thing you're going to do with a kid, and you just plug this into that device, it won't always work. It certainly will not work if the pin here, if the tip is center negative, this device simply won't work. If it's center positive, this thing will work up to a certain current and with certain kinds of loads. But in certain things like motors, like bubble blowers, we've had problems with it. 12 volt, it doesn't like 12 volt devices and things like that. So we actually made a switch isolator by hand. And basically what it does is it has an input jack for this, and then it has a relay like this, a much smaller version of that relay, and then it has an output jack as well. So basically it just sits there, and when you hit this switch, it signals the relay, which then can control anything. Probably a total of $8 in parts. Really handy for people to have in their arsenal when they're trying to get maybe somebody who's using a honeybee or an IR switch or even like an EMG switch, and they want it to control something that's not electronic, something that's electrical. It lets them do that. That's something where if you try to do it by hand, it is there's a lot of wires. It's kind of a pain in the butt, but it's something that we can actually make on a PCB very easily. So that's one of the projects. The other project actually just came up over the last day or so. We have a problem with Kylie's door. And let me see if I can show you this. This is, let me see if I can just show it this way. There you go. So this is actually a good PCB to talk about in terms of something that might be useful for us. Basically, it's a board that holds one chip and that then enables a microcontroller to do something much more useful. It solves a problem we have with one of the boards we use, the ESP8266. It doesn't have any analog inputs. It has no real analog inputs. And that's a problem if you want to do something like the door for Kylie. It needs to read a potentiometer. And that's an analog input. So it can't do that. We worked around it for her, but if you wanted to do something where you were reading a joystick or two joysticks, you really couldn't do that without more analog inputs than it supports. Yet it's the easiest Wi-Fi device there is. So it's the easiest way to get something on the internet and also the lowest cost. So this board actually adds analog inputs to an ESP8266. It's a really easy board to use, and all you've got to do is stick the chip in here and solder down the 8 pins on each side. It's got 16 pins, and then all of a sudden you're kind of good. It just is going to work. So that's an easy one. The last thing that I'll probably talk about is something where we actually have a fab house do some assembly as well. So for example, something like this. See if I can get you a good picture. I don't know if we're going to do something from scratch or if I will walk you through how we got this board. Let me take off the microcontroller. This board done. So this, not only did we get a PCB board made, which actually looks like this, we not only got the board made in China, we actually had them add all the components to it and put it together for us. And it was not that expensive. So we might talk through that process as well. So I think those are the 3 things we're going to do in this series. The problem that I had was I want to include people who aren't on YouTube in this series. And the reason is that I want to get them involved. I want to get these more technical people who want to help us and don't want to be on Facebook. I want to have them give them a way to engage. So I wanted to do this on YouTube. I really didn't want to have it Facebook only, and then it totally fell apart when I tried to do it. So that's the point of this test we're doing. I appreciate your help. I see people saying thanks for zooming in. So I can see comments on Facebook. I can see comments here, still loud and clear. I have no comments yet on Twitter, but that's not surprising. This is a test feed. So I think I'm going to set up an event on tomorrow night. Hey, Lori, do we have anything for tomorrow night? All right. So tomorrow night, 7 p.m. Eastern, we will set up an event. I'll set it up as an event both on YouTube and on Facebook. I'll invite people, and this time we will not screw up. I'm not entirely sure what I did last time to get it wrong, but I do know how to check it now. So So at least I'll know if I'm doing it wrong next time. So thank you very much. Thank you, Jake. Thank you, Janet. And thank you, everybody who's just hitting like. So I'm glad you like it. We will do this tomorrow night, 7 o'clock. Tomorrow, I think I'm going to focus. If you have comments on whether you think I should do the isolator first or the analog feather wing, let me know. I mean, the analog feather wing basically will take, I happen to have one here. It will take, it will take one of these chips, which is an 8-channel analog to digital converter, and it will create a custom board that basically places it on, let me see if I can even do this without you guys seeing me here. Yeah, I'm not going to be able to do this without bending all these pins. Hold on a sec. So you got to bend the pins to make them square, and then they'll go in. One sec. All right. So it will let you, there you go. It's going to create a custom board that is about the same shape as this proto wing, and then it will wire it up to all the proper pins that we want it to. So the assembly is really easy. You stick in this chip right here, and you're going to just solder down these 16 pins. It's probably the easiest project, the easiest of the projects we've talked about. Maybe I'll do that one first, and then we'll go ahead and send off to PCBWay, have them make the boards, and by the time I do the next one, which should be next week on Tuesday, I should have the boards back, and we can go ahead and do an assembly and then go on to the next board. I think that's a good plan. If you guys have any comments or thoughts about whether that's a good plan, let me know. And again, thank you so much for stopping by and helping me test the YouTube thing. All right?